I'm going to go over the 9.2 quick check. So first off, this little chart is a very useful little chart to help you do your electron configurations. This will be available to you on the test as a blank chart, and if you want to learn to use it, it is very nice. So the idea here is indicate the orbitals being filled. So this guy here would be the 1s, and this would also be the 1s. Then after this whole block here, this is called the s block because it's s orbitals all the way down. So 1s, 2s, 3s, 4s, 5s, 6s, 7s. Okay, over here, these are the P's, and they start with level 2. So it's 2P, 3P, 4P, 5P, 6P, and 7P. Then over here in the middle, these are the transition metals. These are the D's, and they start with level 3. So 3D, 4D, 5D, 6D. And then those two pull-out parts here, these are the F's, and F's start with level 4. So these are the 4F and the 5F. And then the idea is if you wanted to do somebody like, say this element right here, you would say, okay, that's 1s and 2s, 2p, 3s and 3p, and let's say this is 3p1, 3p2, 3p3, something like that. So you can use this as a cheat sheet to help you fill up the orbitals. It shows you the order of the orbitals as well, and it's very simple. So S's start with 1, P's start with 2, D's start with 3, and F's start with 4. So I'm going to take a second and clean this up a little bit and move on to the next question. Now we have nickel. Okay, here's nickel here from the periodic table. So we can see from that we have 28 protons, and since we're not saying this is an ion, then that's also 28 electrons. So we're going to write the long form electron configuration. Well, we could go back and we could use here, so we know nickel is somewhere over here, so it's going to be 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay, so the long form be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. I need to look this up. Now looking on my periodic table, I can see that nickel is way over, so it's going to be 3d8. Again, nickel will be a little over here, so I go, 1, 2, 3, 4, 5, 6, 7, 8. And then there's 2 more elements after that. So the short form, okay, we're going to go back from nickel. The last noble gas before that was argon, and argon represents all of this. So it's argon 4s2, 3d8. Now how many valence electrons? Okay, it turns out that the valence electrons are the largest S and P orbitals, the S and P orbitals farthest out. So the 4s, okay, level 4s, those are going to be the valence electrons. And if we had an atom that, you were to bump into this atom, you would first encounter those 4s2. So there's 2 valence electrons. And everybody in the transition metals have 2 valence electrons. Now, slightly different is Ni2+. Now, first let me tell you what the wrong way to do that. Okay, if you said Ni2+, and they said, well, how many electrons is that? And you'd say, well, 2+ means you lost 2 electrons, so you have 26 electrons. That's perfectly true. If you went through and just filled up 26 electrons like normal, which would be the same thing as if you were doing iron, you would get the wrong answer. What you want to do is to go back and use the neutral nickel and then remove 2 electrons. So looking at this whole set here, which electrons are going to be lost, which 2 electrons will be lost, and those are the 2 that are farthest away, the valence electrons. So we're going to remove the 4s. So notice we put electrons into the 4s before we put them into the 3d, 4s before the 3d, but when we remove them from the 4s before the 3d. So our answer is 1s2, 2s2, 2p6, 3s2, 3p6, skip the 4s2, and it's just 3d8. Now what's the short form? Again, same thing, argon. And we just lose the last part, 3d8. Now how many valence electrons This is where it's a little confusing for different people. I say that there are 0 valence electrons because nickel had 2 and it lost both of them, so I would say that that is 0 valence electrons. Okay, last question. This is just a nice summary. Fill in the number of valence electrons for each element and indicate what charge these would have. So everybody here has 1 valence electron. Everybody in the second column has 2 valence electrons. These all have 3. These all have 4. These all have 5. These all have 6, 7, 8, and helium only has 2. So the concept here is these have, full shells, but this, helium, the shell, can only hold 2. Now, notice here it says, also say what charge these guys would have. Well, hydrogens form +1 ions, so do lithium, and so do sodium, and you can tell that because that 1 electron is very easy to lose. Okay, they're farther out from the nucleus, and there's going to be shielding from the nucleus. Second column, they form 2s. Okay, third column, if they form ions, they're going to form 3s. We're going to skip back to the end. The noble gases, they do not form ions. Okay, they don't gain or lose electrons, and we'll discuss that. But these guys, they would gain 1 electron, and if they do, they'll have the same number as the noble gas. The oxygens, the oxygen family would gain 2. The nitrogens, this is not all that common, but it follows the pattern, they would gain 3. Turns out that carbons and silicons, okay, it's kind of hard to gain or lose 4. They would usually share, they would do more covalent bonding than they would do ionic. And that's the list.